In this example, we're going to have a look at using the laws of logarithms to simplify a differentiation which otherwise we might not be able to approach. To understand the method used in this video, you should already be familiar with these laws, so if you're not, we recommend you take some time to revise them before watching the rest of this video. For reference, we'll quickly recap these laws now. The first says that log of a times b is equal to log a plus log b. The second says that log a divided by b is equal to log a minus log b. And the third, that log a to the power m is m times log a. So, let's have a look at this tricky example. Y is the function x to the power sine x. There's no obvious way to differentiate this directly, so which law for logarithms should we use to try and help? Well, the right hand side has the form x to the power of something, so this looks like the third law might come in useful, if only we had a logarithm on this right hand side. The trick is to take a logarithm of both sides, that way the two sides remain equal. We take the natural logarithm, that is, log to the base e. So we now have ln y is equal to ln x to the power sine x. By law number 3, the right hand side can be written as sine x times ln x. We can now differentiate the right hand side using the product rule. But what about the left hand side? Well, we can differentiate this side too, but we have to bear in mind that y is a function of x, and here we now have y inside another function, so we will have to use the chain rule. So we have d by dx of ln y is equal to d by dx of sine x times ln x. On the left hand side we use the chain rule. Ln y differentiates to 1 over y, but since y is a function of x when we are differentiating with respect to x, we must times by dy by dx. On the right hand side we must use the product rule. So if we put u is equal to sine x, then du by dx is equal to cos x. And if v is equal to ln x, then dv by dx is 1 over x. So, using the product rule, the right hand side becomes sin x times 1 over x plus ln x times cos x. Let's tidy this up. We can write it as sin x plus x times ln x times cos x all over x. Now, we're at the point where we can isolate what we really wanted to get at, which is dy by dx. We do this by multiplying both sides by y. So we have dy by dx equals y times sin x plus x times ln x times cos x all over x. But remember, we know what y is. It's x to the power sine x. So in fact, we have dy by dx is x to the power sine x times sin x plus x times ln x times cos x divided by x. In general, we don't want to see any y's on the right hand side, just x's, which is why we rewrite the y in terms of x.
The moon burst through